Okay, period 8. Here we go. So hopefully these are the answers you got. If not, pause the video, have one person in the class who got it, for each question, find a different person, have them explain it to you. So make sure that you understand why we got the answers we got. If there's still confusion, or if no one got it, which I'm really hoping is not the case, we'll be back tomorrow. Don't you worry. Jazzy is doing a little better today, so we're hoping she's better tomorrow. And my husband's turn is tomorrow. So check your answers for these. Make sure that your index actually looks like an index and doesn't look like it's an exponent, because here sometimes people write their index a little big and then it looks like it's an x to the third, but it's not. So hopefully this made sense so far, but the variable thing should be getting annoying, right? So for example, what we can do is we should be able to see a pattern. So the square root of x, if I simplify that, I'm looking, my index here is 2, so I'm looking for pairs. That actually doesn't simplify. I end up with just square root of x. Square root of x squared, well, the square root and the squared cancel, so I end up with just x. What you can do is you can pause me for a minute and go through these if you'd like, and then bring me back to check your answers. The square root of x to the third is x square root of x, because I would write it as x times x times x, so I have a pair of x's that gets kicked out, right? X to the fourth, well, I would have two pairs of x's that I would kick out, so that would be x squared. X to the fifth would be x squared square root of x, because I'd have two pairs of x's that I could kick out. There's my x squared, right? Two pairs of x's with an x left over. Here would be x to the third. Here, I would have three pairs of x's I could kick out, so that would give me x to the third square root of x. Here, x to the eighth would simplify to x to the fourth. Hopefully you see a pattern. I want you to go ahead and write something down here. Then we want to come up with a rule that we could use for simplifying radicals with variables, specifically square roots with variables. So you should notice that when we have the evens, I want you to take a look at this. When you have the evens, what happens to the exponent of the number that's inside the radical? That's right, you take the exponent and divide it by 2. So we take our exponent, divide it by 2, and that gives us the thing on the outside. That's the x to the something outside. Square root of, if there's any left over, so if there's an extra 1, so like 7 divided by 2 is 3, remainder 1, the 1 remainder is inside. So any remainder stays inside. This is not so clear, so hopefully the words made sense. If I give you something like the square root of 2, sorry, let me try that again. The square root of x to the 200th power, that would become 200 divided by 2 is x to the 100th. If I give you the square root of x to the 51, right? So I would say to myself, okay, 51, that's 1 over 50. So 50 divided by 2 is 25, so that's x to the 25, square root of 1 left over inside. Hopefully that helps. Now, we can notice a similar pattern, not the same pattern, but a similar pattern when it comes to x to the thirds. I did forget cubed root of x to the third right here. So square root of, cubed root of x is not going to simplify, so that's just going to give me, sorry guys, I'm really not trying to make mistakes on you, cubed root of x. Cubed root of x squared doesn't simplify because I don't have 3 x's to kick out. So that stays that. Cubed root of x to the third simplifies to just x, right? The cubed root and this cube will cancel. Here, if I have x to the fourth, I'm going to have how many groups of 3, or how many triplets that I can kick out? That's right, I have 1 triplet, but I still have 1 left over inside the radical. Here we have cubed root of x to the fifth. So how many triplets? That's right, if I line these all up, there's 5. So I can take 3 out, and I'm left with 2 inside. So I'm left with x, cubed root of x squared, Jazzy's asking to come downstairs where Mommy is. You're going to have to forgive me if she makes her way down before I get a chance to finish this and you hear her screaming, Mommy, okay? Alright, if I have x to the 6th, now I have 6 little x's. Imagine in your head 6 little x's. How many groups of 3 can we pull? We can pull 2 groups of 3, so it becomes x to the 2nd. None of the x's are left inside. Here we end up with similar thing here, except now I have one little x left over here, and I have an x squared out here, because I pulled out 2 groups of 3. Same thing here, 2 groups of 3 get pulled out, but this time instead of 1 left over, right, because that would be, 2 groups of 3 would be 6 x's, I'm left with 2 still there. And here we have, how many groups of 3 can we make out of 9 x's? That's right, 3. So take a second to write down a pattern that you see. And what you should notice is that when our index is 3, there are some special things that happen. That's right. I hope you're talking to me. If you're not talking to me, then I don't know. I'm talking to myself. Well, I'm talking to myself anyway. Okay. Never mind. I'm not even going to bother going down this line of conversation. All right. If my exponent is a multiple of 3 and my index is 3, then it just simplifies out, right? So all I'm going to do is I'm going to take my exponent and divide it by 3, right? Any remainder stays inside. That's written really sloppy. I can't help it, sorry. My computer is not the best writing surface. Okay, so for example, the cubed root of x to the 15th. Well, 15 divided by 3 equals 5, so that would be x to the 5th. What if I want the cubed root of x to the 29th? Well, 29 is not divisible by 3, but the closest multiple of 3 to 29 that's under 29 would be 27. So 27 divided by 3 is 9, remainder 2. So that would be x to the 9th, x squared underneath, because there's a remainder 2 underneath. Hope that makes sense. Take a second to kind of think on it, and then I want you to go ahead and do these problems. I will substitute the answers, because I don't want to record them in here until after you've done them. So, or actually, you know what? Let's do this. Mr. or Mrs. Substitute, if you could please pause the video for a second, let the students work on these problems for the next 10 minutes or so. I will put the answers up, and then you can go ahead and hit play again, and they will get to see the answers. Thank you. Okay, ladies and gentlemen, here are the answers. Hopefully those are the answers you got. Again, same thing. If you did not get those answers, please turn to the person next to you, see if they got them, find someone at your table, identify someone in the class who has these answers that can now explain it to you just in case you didn't get them. Okay? Hopefully this went well. Homework will be posted on Blackboard, and if there is time, you can work on the trail that's posted around the room. Otherwise, I'm assuming that this took the whole time, because truthfully it did for the other classes too. So, good luck with the homework. I'm sorry I couldn't be there today. I will see you tomorrow. Have a good one, guys.